Let's learn the basics of SQL. First, you need an installation of it. On Mac and Linux machines, typically SQLite is already installed. SQLite is, I believe, the most commonly installed database in the world. It's used on cell phones, in browsers, in desktop applications, in lots of different cases. And it's a database that's designed for one machine. So it's not usually used if you're building an application with millions of users all over the globe, but the SQL language is the same, whether you're using SQLite, which is a database for one machine, or using a database that's designed for large applications like Postgres or MySQL. So once you have it installed, you go to your terminal and you type SQLite 3. Windows users will need to install this, or if you'd prefer, you can just use the SQLite that's bundled with the Python installation you already have. We include a file called SQLiteshell.py in all of our homework and lab assignments that you can also download for yourself. If you run that, it's a Python file that starts SQLite, so you can work with it without having to go through the installation process. Or you can use this online editor, which students seem to really like, that's built into the course website. But I'll just show you the terminal version. So here I have a terminal. I can start SQLite. I can initialize it with some table that I already have. And then I can select the name of each city from the cities table where the latitude is higher than what we have here in San Francisco at 38. So let's see what's above 40. Oh, New York and Minneapolis are high latitude cities, meaning they're closer to the North Pole. So here we have a SQLite prompt. We write in a query, end it with a semicolon, and we see some results. To format those a little more nicely, most versions of SQLite will have a column mode, where the same query will produce a nicer looking result where you see the column name. And if we selected more than just the name, we wanted the latitude and the longitude as well, we'd see all of the column names. And then this is just a bar to show you that the data is going to begin. And then we see information about each record. Okay, let's get down to business. A select statement is what we're going to study in depth in this course because it's the most important type of statement. It always includes a comma-separated list of column descriptions, and a column description is an expression, optionally followed by as, and a column name. So you can write select, latitude, longitude, or whatever. If you want to give the column a new name, that's what as is for. If you want to have two columns in your result, then you just separate the two different column descriptions by a comma. Each one you can optionally give a new name. You can write down as many of these as you want, but you always need to end with a semicolon. If you select just a string or a number, those are called literals, that will create a table with just one row. And the union of two select statements is a table containing the rows of both. So here we are. I'm going to keep track of the parent and child of a bunch of pretend dogs. Let's just pretend I'm a dog breeder. And I've picked some common names of dogs like Daisy and Hank. And it turns out that I'm building a database to keep track of who was the parent of Hank. Oh, it was Daisy. This would create a one-row table, which is really boring. If I wanted to create a larger table, I could take a one-row table and union it with another one-row table. Here I have two other dogs, Ace and Bella. Here's two more, Ace and Charlie. And if I just keep using union, I'm building a table with more than one row. And even though I draw it as a tree, what I've really created is a table with a parent column and a child column. So I could give that table a name. The result of a select statement is displayed. I can see it, but it's not stored anywhere. If I want to store it, then I use create table to give it a name. This gives the result of a select statement a permanent name, create table, whatever name you want, as, and then the select statement So I would write create table parents as, I could indent this, SQL doesn't care about indentation, but humans sure do. And so I indent it, and then I've created a table. The parents table, the name of the table is here, that's why I wrote it here, and then the names of the columns are parent and child, and here's a history of all the dogs that I have. You might think dogs have 2 parents, but in this table we only keep track of 1. Not the best example I've ever come up with, but let's just go with it. Now, I'll pause here to say that it is unusual to see so many unions. Normally, you don't create tables from scratch. You already have a table of data, and then you want to do something with it. But in this course, we need to have something to work with, and so I've shown you how to build a table out of nothing. And so while this is possible, in a real application, you'd probably already have a table full of information that you cared about, and so you wouldn't end up writing queries like this, but you could if you needed to build a table from scratch.